Find the volume of the solid obtained by rotating the region between the graph of y equals 1/2 the sine squared on x squared. You don't have to know it looks like exactly like this, but I want to draw it for you. Sine of x squared, and then I'm going to throw a square around the whole thing. Okay, that's the function there. And they tell you it goes from 0 to root pi. We're going to rotate this about the y-axis. So we're going to rotate about this y-axis. First question is there a gap between your region and the axis? And the answer is yes. When the answer is yes, it's a question of washer versus shells. When you're in washer, the rectangle that you draw is perpendicular to the axis, and the rectangle that you draw in shells is parallel to the axis. So perpendicular would look like this. And the issue with that is that the variable would be the variable on that one would be in y, because you take that and move it upwards. And with shells, your variable would be in x. Nothing wrong with doing it in y, at first it seems, but when you're in y, that means you have to solve for x. And that's not going to be easy at all with this function. So we rule that out, and we go with shells. So we draw a rectangle that is parallel to the axis. This would be a rectangle that goes like this, parallel to the axis, and then we connect the axis to the rectangle. That distance is the radius, and then how tall that rectangle is the height. So the formula for the volumes using shells, the volume using shells is 2 pi, the integral from some a to b, the radius times the height. And we're going to do a dx. So the radius is attached to the y-axis. The distance off the y-axis is equal to x, and so we're in x, so we can just leave it as an x. This radius is x. The height of the rectangle is the distance up to the function. That's actually end up being the distance off the off the x-axis. Now that's supposed to be y, but since we're in x, we have to say f of x. So the height is the function f of x, which is 1/2 the sine squared on x squared. From a to b, what's the a, what's the b? This rectangle is going to move from x equals 0 to x equals root pi. It's going to move in this direction. So we have the following integral to do. 0 to root pi. We have a 2 pi on the outside. We have an x. We have a half. And then we have the sine on x squared. Let me do it like this with the quantity squared. That's what the volume is going to equal. So the half can come outside and cancel with 2. So we're talking about pi times the integral from 0 to root pi. We have to integrate x times the sine on x squared. That would have been fine if it was just that. It'd be a nice little u sub. They complicate matters by taking this sine and squaring it. But we'll see what we can do with that. It's also going to be a u sub. Okay, great. So let me take this to the next slide over and pick up from there. We have the volume equals pi times the integral from 0 to root pi x times the sine of x squared whole quantity squared dx. We're going to do a u substitution. If I let u be x squared, then du would be 2x dx. So I take half of du to replace x dx. Okay. So we're talking about half times the integral of sine of u, but that's squared. To integrate sine squared, we need an identity. The identity is that the sine squared on let me write it as x. The sine squared of x is 1/2 1 minus the cosine of twice x. That's how we're going to integrate this. When we want to integrate sine squared, we trade it in for this guy. We already have the half that's here, and now we're going to have another half. 1 minus the cosine of twice u. Okay. So let's call it a fourth. When we integrate the 1, we're going to get a u. When we integrate this guy, you would think it would just be the sine of twice u, but if it was just that, then the chain rule would give you a factor of 2. Since that factor isn't out there, then there must be a factor of a half out here, and then the sign in between these is a minus. And don't forget about the fourth on the outside. And now you've integrated. Your choice as to whether you want to switch your limits of integration or go back. I tend to go back, and so we have the antiderivative. We have the pi already, and now we're going to have the fourth. So pi over 4. What was u? U was x squared. So x squared times, minus 1/2 of the sine of twice x squared. And we're going to evaluate this from 0 to root pi. That's going to be our volume. Keep the pi over 4 on the outside. We plug a root pi in. We square the root pi. We just get pi. But the sine of 2 pi, after squaring the pi, you get sine of 2 pi. That's just 0 though. That's the upper limit. Just pi. The lower limit is 0, and then the sine of 0 is also 0. So we just have pi over 4 times the pi for a final answer of pi squared over 4.